So with the second theorem, it's basically the opposite of the first theorem. Here we are dealing with a perpendicular bisector of a chord. They are basically telling you that there's a perpendicular line that is bisecting a chord. Remember in the first theorem, we dealt with perpendicular from a center to a chord that will bisect a chord. But this time they're telling you this one is perpendicular and it is actually bisecting the chord. So all that we need to do is to figure out or to prove that it passes through the center. So it's quite the opposite. Now, I need to draw your attention to something that is very, very important. With this one, we're going to use what we call contradiction. So a contradiction is you basically saying something that is quite the opposite. For instance, an example, you would say, I love mathematics, I pass mathematics, right? But you do not practice. So when you do not practice, we can assume that you are not going to pass or you're not going to do very well, right? You might scrape through, but you are not going to actually do well. So you are contradicting yourself to say, no, I get distinctions in mathematics, but you never ever practice a single day. So that's basically a contradiction. So how do we do this? First of all, we're going to draw this. We're going to make sure that whatever that they've given us, that there's a perpendicular bisector, there's a line that is perpendicular to a chord and it's already bisecting it, right? Then we're going to draw a fictitious line and we're just going to draw it randomly. We can draw it from B to P, right? Then we're going to say this line does not pass through a center as I've drawn it there. So the plan here is to prove yourself wrong that, wait, this cannot be a perpendicular bisector, right? But you'll understand as I explain. So we are given a chord AC of a circle with center P with B on AC. So you can see B is actually on AC. And we are also given that AB is equals to BC because remember, it's a perpendicular bisector, right? So all that we have to prove is that this line P or the point P actually is on OB, because if we can prove that, then we'll know that this actual line PB lies on OB, right? So to prove that, we're going to use contradiction, right? So suppose the center of P of the circle does not lie on OB, right? That's what we are assuming. Then we can assume that angle OBP, which is OBP, which means this angle R is greater than 0, right? Basically, it's positive, right? Okay, good. So to do this, right, we are going to make sure that angle OBP, right, angle OBP plus angle OBA are equal to 90. So that's us assuming, right? Because that's the line from the center to the midpoint, right? So what are we basically trying to prove here? We are trying to prove that, wait, if angle OBA, as we are given OBA, it's actually 90 degrees, because we can see that, remember, these are vertically opposite angles, this one and this one. So if this one is 90, this one will definitely be 90, right? We know that OB is perpendicular to AC because we're given, right? So which is contradiction? Why? Because of if OBA is 90, this has to be 0 for this to be 90 degrees, right? Right? That's good. So it means OBA is 90 already, right? Pardon me. This should be 90 and this should be 0. The other way around. I actually got them the other way around. So we are going to see OBA is 90 and that's it. So this one works out to be 0, which is OBP, this. Remember we said initially it was positive, it was greater than 0. Remember we said it's greater than 0 degrees. So now we found out that no, it's actually not greater than 0. It is actually 0, making this line fall directly here. Make sense? That's it. So we've basically proved that OBP is 0 and therefore P lies on OB. That's all we needed to find out. But let's do this using an example. Let's prove this using an example. All right. So they say calculate the length of AB if CDE passes through the center of the circle C. Right? So you can see that this OA and OB, right, are ready, right? Okay, let me wrap that out just so I don't mess up anything there. Okay, back with colors. There we go. Right. So we're going to draw a line C, D, E, right, passing through center C. So what do we know? We know a couple of things. We know that CDE is 13 centimeter because we are given there. It's basically there, right? And it means they are all ready. So it means CA is also 13 centimeter and CB is also 13 centimeters because they are all ready, right? Then we can solve DE, right? Or CD, in fact. We know that if that one is 13 and DE is 1 centimeter, it means CD is 12 centimeter. All right. Then we can use Pythagoras theorem where we find CD is 12. DB is actually what we are looking for. Right? DB is what we are looking for. And then 13 CB is 13 squared. We found that DB is 5. This means if DB is 5, it means AB is 10, right? Because it's basically a chord, right? So AB is 10. So there you have it. There you have it. It should be easy. It should not be a problem. On to the next video regarding an angle at center is twice the angle at the circumference. Thank you.